Still, it's based on Beer-Lambert law. A is equal to E or epsilon CL. Okay, it's based on that. I'm not trying to discuss what is Beer-Lambert law here too much. Okay, because we want to understand the machine. When we try to understand the machine, should be automatically we will understand this Beer-Lambert law. Read about it, please. Okay, that's it. That is the principle. We want to move on to the next topic or the next slide. The one that I've shown yesterday, the compartment or what's inside the machine itself. Okay. First, we will see the radiation source or the light source. Okay, saya lukis ni mata ni, light source, and then we'll see the sample cell or the atomizer. Here we don't call it a sample cell, we'll call it an atomizer, where atom is made. Okay, the burning process. We will see it in about 1 minute. And then we will see a monochromator. This is a monochromator. And then we go to the detector and we see what's being absorbed, how much is being absorbed, not how. And finally, we see the readout device. What about this one? Okay, this is special. It only goes here because the sample will be introduced to the machine in liquid form. But the analysis process will carry it out in atom form or in gaseous form. So the sample has to be transformed first. And the transformation process or the introduction process is special. We will look at it also after this. Okay, so this is it. About 6 or 5 of them. Please remember. And if we are asked to draw this diagram, please make sure this one stays out here. Okay? Don't put it here or here. It should be connecting to the atomizer. Okay? Then I want to show everybody here what does this machine looks like. Okay? We will look at it. But inshallah, next week, we will try to look at all the machines that we have studied, that we have discussed in real time, okay? Or in food science laboratory, okay? But this one is, I don't know, maybe this in Canada or something. Nampak tak? Can everybody see the video?
Doktor.
Nampak kan?
Yes.
Yes, Doktor.
This instrument is provided by Varian and its model is AA240. So we're going to have a look at how we can actually atomize the sample and then see its absorbance. So the first part of this type of analysis is to introduce the sample into the system. And that's done using this fine capillary tube. So our sample will be drawn up into this capillary tube and it's going to make its way into the nebulizer. So just pull this heat guard off and look at what's going on in here. So sample is drawn into the capillary tube and this white section here is called the nebulizer. And this is where the sample that's already in a mist becomes an even finer mist, a very, very fine spray of droplets of your solution containing the sample metals. Those droplets are created by the nebulizer, are moved using carrier gases into this burner slot, which is where the flame is. So the gases have 2 roles. Their first role is to sweep your sample of droplets into the flame, and secondly, once they're in the flame, to act as a fuel.
Sweep tu bawah Sweep adalah
high temperatures over 1,000 degrees.
Sweep tu maknanya bawa, sapu. Maksudnya gas guna dia untuk membawa kita punya sampel dan kemudian akan membakar sampel tu. Dia akan jadi sumber bakar, fuel, bahan bakar.
And above, depending on the mixture of gases that we use. Once our sample gets into our flame, 3 different things happen. First is desolvation, and all that means is that the solvent that's used.
Okay, the first is desolvation. This is in the sample introduction system or in the atomizer. Okay, first is desolvation. Tulis tu.
Used to dissolve our sample is burnt off. So we're left with compounds. And then the compounds break down or decompose because of the really high temperatures. And then we have free atoms and ions, which are up there in our flame. At this point, a light is shone through the base of the flame. And this is where we can...
Okay, dekat sini tempat yang ditunjuk ni akan ada api sama macam, akan ada api macam penunu bangsen ataupun macam dapur gas, api biru.
Get excitation of electrons that are within the atom or nation of the base of the flame. And this is where we can get excitation of electrons that are within the atom or ion that we're interested in looking at. And this light comes from a hollow cathode lamp. Over here in this section of the instrument, we have a range of hollow cathode lamps.
Okay, ini adalah light source. Dipanggil hollow cathode lamp. Semuanya hollow cathode lamp.
Now in your textbooks you might have seen some instruments and they just have one hollow cathode lamp. The lamp is specific for different elements. So for instance, this top lamp we use for calcium, magnesium or aluminium metals. So our light will be generated from this lamp at set wavelengths and will then be able to pass through our sun. So at the moment what we will have is a range of different atoms and ions burning in our flame. And as we pass the light through, that light is specific for a particular element. So if I was looking for magnesium, a specific wavelength of light is going to be passing through my flame. Any magnesium atoms will be excited, their electrons will be excited to a higher energy level. And then, as they return to their ground state, they'll give off that energy in the form of photons of light. So what will happen is these photons of light will pass through to the detector, which is in this part of the instrument. And the instrument will actually be able to see an increase in the amount of light that's transmitted between what comes through normally.
Okay, kita ada light source di sini. Kemudian kita ada atomizer. Dan di bawah ni yang piping ni, ini adalah introduction system. Dan yang di hujung yang tangan dia ni, ini adalah detector.
And when you put a sample in, extra light's going to be given off. And that's converted to a function of absorbance. And so we can use an AAS to determine what's present in our sample. So if I'm looking for magnesium, if there's any magnesium present, and secondly, how much is present by how much light or energy is being absorbed.
Okay, itu yang saya kata tadi. Dia boleh detect dan dia boleh dapat quantity. The machine can detect any element, any presence of the element, and the amount of that certain element presence also can be detected, can be calculated, can be measured, sorry.